Hello and welcome to the supplementary video of section 3.8. In class, we will use implicit differentiation to calculate the derivatives of the 6 inverse trigonometric functions. As many students are unfamiliar with inverse trig functions, they will be the focus of this pre-lecture video. The 6 trigonometric functions have an angle input and an output that represents a ratio of triangle lengths. The inverse trigonometric functions do the opposite. They have an input which represents the ratio of triangle side lengths, and an output that represents an angle. So why do we care about the derivative of these functions? There are many instances where knowing how fast something turns is important. For example, a bike is traveling a certain speed. At what rate does the angle the pedal makes with the horizontal change? Or take an analog clock. When it's ticking away, keeping time accurately, at what rate does the angle between the minute and the hour hand change? In both of these examples, you need one of the 6 inverse trigonometric functions to answer the question. A warning on notation. It is common to see the inverse trigonometric functions represented with an exponent of -1. This can be deceiving because we are interested in the function inverse, not the multiplicative inverse. The function inverse is a concept tied to composition. A function composed with its inverse, or the inverse composed with the original function, is the identity function x. The function inverse of cosine is written either as arc cosine or cosine inverse, which is not to be confused with the multiplicative inverse of cosine, 1 over cosine, which is the secant function. We are interested in the inverse trigonometric functions. However, when we look at the graph of sine, it is clear that many different angles give the same ratio. So the inverse will have a single ratio corresponding to an infinite number of angles. This will fail the vertical line test and fail to define a function. Since the trig functions are periodic, trigonometric functions fail the horizontal line test, and therefore do not have inverses. For this reason, the inverse trigonometric functions are defined on a restricted domain. The inverse trigonometric functions are defined as the inverse of certain parts of the trig function. We will restrict the domain that we inverse to avoid failing the horizontal line test. For example, look at the graph of cosine. We choose the largest continuous piece, closest to 0, that will pass the horizontal line test, and restrict the domain to it. So arc cosine is defined on the interval -1 to 1 and has the range 0 to pi. It is continuous at all points except the endpoints. Take a look at the graph of sine. We choose the largest continuous piece closest to 0 that will pass the horizontal line test and restrict the domain to it. So arc sine is defined on the interval -1 to 1 and has the range -pi/2 to +pi/2. It is continuous at all points except the endpoints. And finally, take a look at the graph of tangent. We choose the largest continuous piece closest to 0 that will pass the horizontal line test, and we restrict the domain to it. So arctangent is defined for all values -∞ to +∞, and has the range -pi/2 to +pi/2. It is continuous at all points, and it has the horizontal asymptotes y = pi/2 and y = -pi/2. For example, the value of both arc sine at square root of 3/2 and arc cosine at 1/2 is pi/3. But due to range restrictions, arc cosine of -1/2 is 2 pi/3, not 4 pi/3, and arc cosine of -square root of 3/2 is -pi/3, not 5 pi/3 or 4 pi/3. Observe that the range of the inverse trig functions depends on the trig function being inverted. Cosine comes from the first and second quadrants of the unit circle, so that is where the range of arc cosine will lie. While sine and tangent come from the first and fourth quadrants of the unit circle, so that is where the range of arc sine and arc tangent will lie. The graphs of the inverse trig functions are smooth and have derivatives. In class, we will calculate the derivative of the inverse trigonometric functions using implicit differentiation. You've seen the basics, now gain mastery through practice and study.